Now that our PCR reactions have been prepared, they are going to be loaded into a C1000 thermal cycler, otherwise known as a PCR machine. So Bob has already entered the sample volume, that is 25 microlitres per reaction, and the sample ID is whatever you would like to call it. In this case, Bob has just put in wheat. All right, Bob, you can load your tubes.
Press OK.
Yep.
So now this is actually going to heat up the reaction to 95 degrees for
Here
3
we go.
minutes.
So here are the cycling parameters. All right, talk us through them, Bob.
So it starts off, essentially heats up everything to 95 degrees for 3 minutes. And that's step 1. Then it goes to step 2. Step 2 is actually also 95 degrees, but it's only for 30 seconds. And this is known as our denaturation step. Then the next step is what's known as the annealing step, and that's where the actual primers actually bind to the single-stranded DNA. And that's done at 55 degrees. So that's the right temperature for the primers to bind to the DNA, the complementary strand of the primers. And then we go to the next step, which is known as the extension step, and that's where DNA synthesis occurs, where the primers or the oligonucleotides act as the initial strand, and then for the DNA polymerase comes along and actually continues synthesizing a complementary strand to the single-stranded DNA. And it goes actually from step 4 back to step 2, and it continues doing this for 35 cycles.
Okay.
And then once we get to, so that's actually step 5.
Where are
step
the cycles?
5.
Oh, here we go.
Step 5.
35 cycles, yeah.
And then after we've repeated this from step 3 to 5 35 times, then we go to step 6, which is just essentially allows any partially synthesized or incomplete synthesized strands of DNA to be gone to completion. So that's just 72 degrees, which is the extension step for 5 minutes. And after that we go to step 7, which is just to keep this reaction there at 12 degrees. So therefore no more DNA synthesis is occurring at 12 degrees.
Okay, that's great. And I'll just add here that the reason this temperature is used, 72 degrees Celsius, because that is the optimum temperature at which the DNA polymerase enzyme works.
Yeah, we can synthesize the complementary strand.
That's correct. All right. Thank you, Bob.
Thank you, Barrett.